to open the distributor notebook file called learning materials and just ignore the functions py because that was just supporting documents. So just go to your distributor notebook and go to the folder and go into the learning material, and you can open this learning material.
And just in case you can do more long.
Okay. So everyone all set? Are we on the same page of this one? The PopGen learning material. So so today we're going to try the population analysis software called PopGen. So we're going to use this software to weighting the samples from surveys, and we want to create the synthetic populations for entire region areas. So the first step, I want you guys to click on this, the first one called install PopGen. So make sure that the PopGen can be installed on your laptop. So click on this one. And then after you, it show that it has been installed successfully. And then you can click on this one, check the version of your PopGen is 3.03.
Is it the latest version of PopGen?
Is it later? Is the previous version of PopGen? So yeah, my update is coming. So okay. Yeah. Yeah.
So if anybody is not with fan, right, please raise your hand so that way we can make sure all of you are following along and keep it in sync with fan.
So, and later we're going to run these blocks to import all this kind of supporting material for today's class, supporting package. So if you have the error, probably because you don't have this kind of package, you can install this package again. So just click on this one, the import all this kind of numpys, pandas, and math and functions. And then we can go to the data folders. And the data we're going to use is called Arizona dataset. So it's within the data folders. And here is the overview of the data folder structures. So we're going to using 12 CSV files as our input for PopGen. So it can be divided by 4 parts. The first two is the marginal files. So it's a regional marginal file as well as a geo marginal files. So one is stand for higher level geographic marginal file, and one is stand for lower level geographic marginal files. And also we're going to have this data sample files, which is including household sample file, person sample file, and group quarter sample files. So this is our the service samples that we collect from our site. And then we have these 3 geographic correspondence file, which is mapping the different layer of geographics for our PopGen. So you can see that from this this graph. So basically, we're going to create a population for Maricopa counties, and we do the surveys on the middle layer, which is Puma layers, and for entire Maricopa. But we have like marginal data set coming from different like source. The one source is called the county subdivision, which is higher level, on the top, and one is coming from the lower layer, which is sensor track, which is very high resolution. So this kind of 2 layer has a marginal data set, and we want to weight our sample to the marginal data set and create a synthetic population for entire regions. So that's the purpose of PopGen.
So basically, we have a survey. So this is the American Community Survey. Okay. So this is for the census. So they do survey of individuals. So this represents 2.5% of the entire population. Okay. And that survey is collected at the Puma level. Okay, so it really doesn't matter for us. This is just to show you that this is an intermediate layer. But our goal is basically synthesize a population using this survey, right? So we have like, let's say 100 people and my population is like 10,000, right? So I'm going to use that survey as a seed, okay, to explode and create the 10,000 people, okay, the full population basically. Okay, in this population synthesis, in this exercise, right, we have two goals. So one of them, the full population at the region level, okay, will represent my marginal totals. So when we say marginal, so marginals are my distributions, okay, of the control variables that I want my synthesized population to be representative of. Okay, for example, if I am going to, let's say, synthesize a population, I want it to mimic the gender distribution at the region level. Okay, the full 10,000 people, if you take their gender distribution, okay, it has to match the gender split at the region level, the income distribution, it has to match that, right? So the control variables means is which attribute or which variable, which characteristics of the population I want to basically use to match, okay? So that the created population will be representative of those distributions. Okay, so this is the full trick. The second trick here we have, okay, we are matching at the region level. Okay, and at the same time, I know the distributions, the control variable distributions at the smaller geographies, right? This is the neighborhood level you can think of, or the zip codes. Here they are the census tracts. For each census tract, I also know the distributions, right? The gender distribution. So the synthesized population, not only matching the high-level geographical distributions, but also it's going to match every one of those census tract distributions. Okay, so if you take a small sample as one of the census tracts, so how many census tracts, whatever you have, maybe just 1,000, right? Depends on the larger geography. So whichever census tract you are going to pull, right, and look at their distributions for the control variables, you'll know that you have to make sure that it is matching almost perfect. Okay, it is matching at the high level, it is matching at the low level. Okay, so this is basically the optimization problem we are facing here. Okay, so the seed that we are going to use is the survey. Okay, so this is what we call here in the PopGen term, we have the sample data. Okay, the sample represents the seed, the survey. Okay, and then we have the region marginals. Okay, so this is the higher level marginals. So how many regions we have?
We have 9 regions, which is
We have 9
currently
regions,
sufficient.
but we are only going to synthesize for one of them. And for each regions, we have the census tracts. Like,
corresponding census tract. Yeah.
like multiple census tracts, right? So each region is basically have multiple census tracts. Okay, so we have files, right? At the region level, so these are the marginals that shows the distributions for the regions. We have another set of marginals that shows the distributions, okay, for the control variables for each census tract. And then we have another set of files that is our seed. So this is the sample files. And then the fourth set of files represents the mapping code. Okay, we know that census tracts have unique IDs. So which census tract belongs to which region? Okay, so this is how you set up the input file.
Yeah, thank you so much. Yeah. So let's go to the sample input files. So in our data sets, we're going to have these 3 files. Well, the first one is household sample file, and the person's sample file, and group quarter sample file. So basically, this kind of survey is household surveys in like survey each household, and the sample person sample is they also sampling the survey the person within that household. So they also like survey the people within that household. So if the person is corresponding to household as well.
So we have every person in the household.
Exactly.
Okay,
Yeah.
so you have every member of the households.
Mm-hmm.
Okay, that is also surveyed, and their personal information is available in the person file.
Mm-hmm.
And their household level information is available at the household file.
Mm-hmm.
And then there are the group quarters. So what are the group quarters?
So group quarter is stand for the people living in like the school and military or this kind of
Okay, so
facilities.
it's-
Yeah.
Right? So they are not represented as households, but they are part of the population, so we capture them as group quarters margin. So we synthesize them because we are synthesizing the full population.
So let's read all of three of these files, and let's go to the.
So you read the files.
Yeah. So let's go to the household sample data set let's check the data set. Just click on this one. And you can see that for the household sample tables, we have units household ID, which calls HID. And as well, we have the sample geographic unit IDs, which is sample geos, which is coming from this layer's resolutions. So that's a sample ID called sample geos. And also we have bunch of variable, the Pumas, yeah.
Right, so it's belong to which region to do this codes, right?
Yeah.
Okay.
Yeah. And also we have the household variable provides in two special resolution. So for the geo level on the left and the region level on the right. So for region level, is the variables start with art. So for example, in this table, we have the household income and household size for geo level, as well as the household income and household size for region level.
Why do we have this distinction?
So
Why do we need two income variables? Is it
because that we need to weight the sample to two regions, and the two regions has different like resolutions of the different like marginal distributions of this variable.
I see.
So that's why we control this like at the same time.
Okay, is household income variable and region household income
Is it
variable
exactly the same? Yeah, on a sample survey, they are identical.
Okay, so they are identical.
They are identical.
But you just name it one more time.
Yeah.
And create a duplicate
Yeah.
because you are using for a different computation in
Yeah.
the software.
Yeah, you can consider that each variable considered as a candidate for the control variable later for the weighting process and the software process. So because we need to have control variable to weight to two level, so that's why we need two separate like control variable for the same like geographic like attributes.
What is household total?
So the household total is just the count of the household. So here that each household it has number one. So is to control for the total number of households in entire region. It's not a variable. It's just each household come with one.
So if you want to have multiple households of the same thing, you can just increase that?
No. So this just like the tracking of each household. So the count of household is one. For example, you don't want to you don't want to create a populations follow the marginal distribution. You just want to create a population to meet the number of total region. Then you just control for the household total. So it can because it just has one dimension. So other variable have different category like 1, 2, 3, 4, 5, and these stand for different distribution. Yeah. So we can look at the total number in our household sample size. You can see that there's about like 128,000. So this is
across 9 regions.
across 9 regions for entire.
In the Maricopa County.
Yeah.
9 regions. This represents the full household
Samples. I think it's from ACS. It's from census, yeah, service. Yeah, and also we can check our personal sample size, and you can see that for a personal sample size, we still using the household ID as their unique identified, and as well as PIDs with person ID. So you can see that it actually showing as the for one household, it has 2 people. So that's how we record this kind of personal information in the personal template. Like an HTS, like the tree table, the household table. If you we try NHTS with, yeah. So as you can see for this surveys, we actually like sampling like about 300,000 people within the previous like 128,000 households. So that's the person level sample data sets.
Again, the survey data.
Yeah, survey data is all survey data. And we can also check our group quarter samples as well. So on the group quarter sample table, we don't have like a group quarter specific variable, just the count the number of group quarters. And you can see that in our survey data set, we have about like 15,000 group quarters, which is also using share the same HID. They are considered special types of household.
So each individual in group order
Mm-hmm.
is considered one household.
Yeah, so that's why they also using the HID as the identifier ID. So, and then after we create this reading this sample size, we actually the PopGen can using this information to create the initial seed data for IPF, which is algorithm for weighting called iterated proportional feedings. So as you can see that this is from last week class. We create a joint distribution of 2 variables, and this is numbered from the survey sample size. And then we're going to have the marginals from the two level marginal variable on 2 sides, and we're going to literally algorithm to make this seed, expand this seed to the marginal. So that's the first process of PopGen. We're going to weight that. So we can also quickly show that in our sample data set, we can just using the cross tab. For example, we can choosing the household size and household income. And if you run this, and you can see this joint distributions. If we're going to using these 2 variables as control variable, we're going to weight this joint. We're going to use this joint distribution as our C table for the IPF algorithms. And if we have more variables, control variable, then going to be like 3D, and it's going to be multiple dimensional tensors for the weighting.
Part of the or is this part of the synthesizer?
So this is both part of the weighting and the synthesized parts, because the synthesized parts, we're going to expand this each entries, the joint distribution to the marginal one, and we're going to also run this ones to make sure it's integers. And then we're going to, when during the synthesis part, we're going to using our weight as our like select probability, and we're going to randomly select the household, and until it meets these each entries as joint distributions, and then we finish the population analysis. So that's both process. So if you remember that in the last week class, Dr. Pendyala mentioned that we're going to using this expanded set after IPF each entry as a constraint for later called IPU reweighting. So we're going to add the entries to this part as our constraint for the IPU algorithms. And then we're using the IPU algorithm to get our individual records weights. So this is the process we're getting the weights. So the for the IPF in our PopGens, we just memory the joint distribution, these values. But for the IPU, we're going to get the individual weights. So it needs to be because our PopGen can handle the across 2 level about the person and the household. So you can see that we're going to join the person variable into our household variable. And this is actually for the household variable is the on-hot encoding. So for each category, we have the 1 or 0. And for each household ID, for each category of personal type, we're going to count the person numbers for in this kind of category. So we can also try that in our example. So for example, this is based on our sample size. This is the initial frequencies matrix for the IPU algorithms. And after these algorithms, we're going to have the weight. And then using the weights, we're going to sample the data set to create our expanding synthetic population. And also, let's go to the second part of the data inputs, which is called the marginal input for PopGens. So as I mentioned before, that we need to weight our survey sample to both of these two region marginal level. So we're going to have two level, once again, two level of marginal data, which is geo level and the region level marginal data set. And it also show as personal marginal and household marginal and group quarter marginals. So let's read this marginal data set. So this is the data structure we need to prepare for PopGen, because PopGen can only read this kind of marginal file. So later, if we want to using PopGen for another weighting or another syntheticity, you need to prepare your margin data sets for this kind of cells. So on the first layer, first row is our variables, and the second row is we put all the category of of the variables. And then for our column, the first column is our geo ID. And then we put the marginal values, distributions within this table. So this is the marginal data set for households and for the geo level. And and this, okay. And this is our geo level household marginal data inputs. As you can see that this basically the same, but for this one, we list as the each geo ID, but for this one is higher level, so we only have 9 regions. So it's listed as 9 regions.
So it's basically showing how many households you need to have for each of these 9 regions, right? In the first column. And then the second through the 7th column, or to the 8th column, so 1 to the 7th, this is showing the household size. Right? So for each of household size categories, right? So 1-member households, 2-member households. So how many households you need to synthesize, you need to have a dent, right? For each of these regions. Yeah.
So basically, each entry can explain that for region 1, there's probably 300,000 populations of household size 1. So it's the marginal data set for sensors. Yeah. And we can check if we run the second code, we're going to check the summary of geographic units in marginal and sample data set. So we can see that.
You don't have the joint distribution of the margins, right? So it is not available like this in our case. At the census level, you don't have a marginal distribution that shows the binary distribution, let's say, between income and household size.
We don't have that. We don't have that. We don't have that. Yeah, because from the census website, we only have the marginal distribution of 1 variable, 2 variable. So there's no joint.
Have that capable. Okay.
Yeah, if we have that, we probably can consider a special type of the variable adding into our marginal inputs. Okay. And so if you run this code, you can see that in our data set, we do have 9 regions as a marginal data set, and for geometry data, we have 916 geos, and for sample data geos, we have 54, which is Puma level. So this is the sensor county subdivisions and sensor checks, and also the survey Puma level. So later we have this kind of different kind of the geographic units. We need to map each other because we need to know that what this kind of the service coming the record is coming from. So we're going to map in that. So that's why we need a mapping file in this kind of.
So before you move, let's say you have a survey, right? Collected across the United States. Just one single survey.
Yeah.
Okay, let's say you know their states information for individuals.
Yeah.
And you want to date your survey only using PopGen.
Yes.
Okay? And you want to date it such that it is weighted to match, right? A set of control variables, let's say income, household size, gender, education, across 9 census divisions in the United States. So if you go to the summary files, you'll summarize the 3 lines. Okay. So for your regional marginal data, you have 9 regions. These are the 9 census divisions, right?
Yeah. Yeah.
For geo-marginal data, we are not considering that.
Yeah.
Right? We are not considering. So a single.
So we can in this teaching section we're going to show the weighting for meet like a 2-level marginal simultaneously. But actually we can turn off the one region. We can only weightings for one region. That's what we did for our DAS service, LeapPy service, because we only have one marginal level. But here we just want to show that PopGen has this ability to weighting our sample to multiple regions. To consider two regions and 2 levels marginal data set.
Okay.
Yeah. And so here is our geographic mapping file. We have 3 files. The first one is mapping from the region resolution to geo resolution, and the geo resolution sample geo resolution, which is from sensor trap to Puma level, and also the region to the samples, which is from the county subdivisions to the Pumas.
So this is just basically a dictionary for PopGen to interpret.
To understand.
Census tract belongs to which region?
Yeah.
Which Puma geography belongs to which region?
Yes. And because as you can see that for the marginal ones, we have a higher level and lower level. But for them, we have 2 different like marginal data input. We need to ensure that because this is mapping, we need to ensure that we applicate the lower marginal input is the same as the higher marginal input. Otherwise, that it will create some differences. Inconsistencies. So will cause the weighting problem. So that's why we can see that. Let's read the table. And this one is we can count how many you.
The multi-layer PopGen.
Yeah.
Is your application the
Yeah.
demonstration of multi-layer PopGen?
Yeah.
Okay, so you have region level marginals, geo, whatever
Yeah.
that is.
Sensor tracks. Yeah.
And the sample data is Puma.
Yeah. And if you read the mapping file, you can see that for region 1, the actual account for like 720 geos. So that must be like Phoenix areas. And then for the region 9, we only have like two, maybe it's the suburbans or rural areas.
Because it is the sum.
The sum.
It is the sum of the regions.
Yeah.
How many regions you have, total 9, then the total number of geos.
And we can also see that the mapping file, if we select filter the region equal to 8, we want to see how many units geos within the 8. We can see that this is the specific geo units belong to the region 8.
58 geos.
Yeah.
For the region 8.
58, yeah. And this one is the mapping between the sample geo with the Pumas and the sensor traps. And you can see that for the 35 Pumas regions, and like it, including all of these like sensors fall into to each Pumas region. Yeah, because we want to check the consistency between the geo marginal input and the region marginal input. So we're going to group the geo marginal based on the mapping.
In terms of the total number of.
Yeah.
So in your census tract marginals, their sums, right? The totals for the census tracts has to match your upper level.
Yeah.
Region. So this is just showing that consistent.
Yeah. So this is if we group in all of this our geo marginal inputs, and we get this table, and if we compare this one with later the regional one, so we can see that it's actually consistent. So that means that these two marginals provided into the PopGen are correct and consistent. So we can run the weighting and the population analysis. Yeah. And so we already go over all our input variables, and now we need to create a new population. We want to create population to matching the marginal distributions. So first of all, we want to compare how our sample size distribution look like compared to the marginal distributions. So in the section 4, you can try this code to check the distribution discrepancies. For example, if you run this code, and we can select one regions like we want to compare, and select one control variable we want to compare. For example, we can type region, and we can compare our sample size, for example, with region 1, and can set our control variables, which is household size. So if we select regions, we must select the right variable with R. So here it gives you the distributions difference between the sample surveys and the marginal distribution.
So this is basically. Okay, so which one is survey?
Survey is pumps.
Yeah, survey is pumps.
Yeah.
Survey is pumps, and then the marginals at the census tract level.
Census, yeah.
So for region 1, is this the region 1?
It's region 1. We have 1 million marginal data sets about
So this is showing household size distribution for region, but all the census tracts within that region, right? What percent?
Their totals match anyway, right? For the 1 million households, for the region 1, this is the distribution. The distribution of the household size.
Oh, okay. And you have 120,000 pumps records.
Yeah.
For that region.
For region.
No.
This is in the survey.
Yep.
Also, this is the total.
So
This is region 1.
No, the survey data.
The survey data is a set. We consider all our survey for 100,000.
So is this distribution for region 1?
Yeah.
So the blue is region 1.
Oh, so those
orange is.
numbers are not region.
Yeah, I can try another one. For example, we can try the region number, for example, number 8, and still household size. And this one, we put the survey one, sample size is the same because we consider entire people one. And for the marginal one, because it follow the region marginal, and this is the distribution of this variable. So you can see that first part of our like PopGen, we need to control the household size for region 8. We need to weight our survey data set to match the marginal distribution, which is the blue one. Right? The blue. Yeah, blue one. Yeah. Sure. Yeah. And we can also check for the personal variable. So for example, let's select regions and region 9 probably. And we can try the person level variables, which is person age, like gender and employee. Let's try employment. So as you can see that the surveys sample data for a person is about 300,000.
So this is our full survey sample. Yeah.
And for the marginal ones is 9,000, and you can see the distribution is quite different on this region. And
So is every region getting the same seed matrix?
Yes.
yeah. So it will only consider one seed, and we're using that one seed to matching.
See for that specific thing, I think you have to run it. You take the subsets from the Puma for each region, and you have to run it 9 times. So wanna control for that.
Yeah. Yeah. And this is all so far is I show you guys all the input files, and the second one is we need to prepare a configuration files to allow the PopGen know what you want to do, like what control variable you want to use for the population synergy and what region you want to select. So if you look at the data folders and data, so you will see that there's a configuration file, which is YAML files, which calls our configuration Arizonas. And if you look at the inside of the file, you're going to have I think, 3 very important parts. So the first part is you just provide the name of your projects and you tell the location of your input data set.
So basically, PopGen.
Yeah,
Right.
yeah.
So when you run into PopGen, first you have your input variables.
Mm-hmm.
So input files that represents the marginals, the mapping dictionary of the geos, right, between geographies, and then the sample. And plus you have the configuration file, okay, where it is basically created and you can also manipulate it here.
Yeah.
Within the input.
Yeah.
So these are all goes into as input files for PopGen to run a scenario.
So I think the YAML file is the file that is human and machine readable file. It's like you prepare data set, but you need to tell like the software what you're going what you want to do. So for example, you're going to select we have 9 regions. What region you're going to create a population for? So we can select one region, region 1, region 2.
Define which region or regions you want to synthesize for.
Yeah.
The population. And you can, I think, disable enable rating or population before rating. And plus you say which variables in household level and person level you want to control for. And also, and what are the variable names in household marginal files, person marginal files, and the sample files, right? Survey files. Yeah. You provide the names. And also you could tell PopGen where your data file located. So for example, here we got located in the files in this kind of folder. And also folder. You give a specific name for that route. Yeah. Right? So what is the scenario? Yeah. And also you list your like a CSV file name here for the software can understand that what they as a data for from. So you can change the right side, but you cannot change the left side. Right? Yeah. Geo the sample is fixed. You cannot change that name, but you need to find you can change the file. For example, here we name the household ID HID. But you can have an household ID or something other names to be here. But the left side is for the software have. Yeah. So here we also list our data file for the configuration file. And then the most important part, we're going to set our control variables. So it's like what kind of, for our generate population, synthetic populations, what kind of distribution you want to like align with.
For example, you want to create populations fully aligned with the marginal distribution of the house, the age, the personal age, or only the household income, or you want to select all of these variables for as control variable. So you can put your control variable here. For example, here we select household income, and the household total is to control the total number of the households within that region. And for the person level, we're going to select the genders and age and employment.
So in total, you have 4 marginal variables, the control variables, right? So at household level, you only control for income. The person level, you are controlling for gender, age, and employment status. Okay, so you only have 4.
Yeah. Yeah, you can increasing or reducing by yourself, depend on your need and your survey data set.
So you can have as many ones, but the running times will be significantly different.
Yeah.
If you have more control variables, the problem gets complicated. So it's going to take more time for PopGen to come.
Why do you call this a TAZ scenario? Those are not TAZs, right?
Yeah, you can call it sensitive tracks.
You can cause, yeah.
It's actually census tracts, right?
Yeah, sensor trace. It should be called sensor trace, yeah. And the last part, important part of the configuration file is like you need to select the region you want to like synthesize. For example, here we select we want to create population for region number 9, and you can replace as 1 or other values, and also you can simultaneously create population for 1 to 9. You can put 1 to 9, 3, 4, 9 here, like create population for entire Maricopa County. But it don't take a while. So, and also for the for geo level, you can create your population for specific for geo level, which is the lower level, marginal distribution. Yeah. So here we can let's run the PopGen together. So for this scenario, we're going to create population for the study region 9. And we're going to control the 4 variables. And then let's go to these 2 lines. Is it running on your laptop? Is it running? Yeah. So here's like a
Slides for region 9?
Yeah, I'm thinking for region 9. Because
Why did you do that?
because it's faster.
Okay, you have only how many geos you have for that?
9. We have 1, 2, 3, 1, 9. I only think 9 for 9. Because 9 only have
You have 9 regions.
2
How
0.
many- Okay, how many census tracts?
So here's the output of the PopGen. You can see the first part going to the IPI for this kind of the sample as I showed before with the C table, and then you do the running frequency for each geo distribution, and then you're going to run the reweighting IPU for based on the IPI results. And as you can see that for region 9, we're going to have these two geo.
Just 2 census tracts.
Yeah, 2 census tracts.
And what is the sample weight sum?
So that means that the total sum of the
So the full region has 4173 households.
well, yeah. So for region number 9, it only
Okay, so
has
this is sample weight at the household.
Yeah.
Okay, not the person level.
If we we give the weight of the household.
Okay, so you are computing household weights while accounting.
Yeah,
for
accounting for
household
percentage.
weights. Okay, yeah, so it is household weights.
Yeah, it's household weight. And you're going to create you can see that you can create a housing population table and person population, which is our
What is the 12 and 13?
is the columns
Oh.
within the data set. And yeah, So if you have this kind of result, means that you run the PopGen successfully on your desktop, on your laptop. And so if you go to the data folder, and if you go into Arizona folder, and you're going to find this folder, and this is actually our result. Yeah. So I can pull on the Tashio's slides. I think he has a slide to. So for this information of the results. And you can see that we have a configuration file, which is tell you how the summary of this running, and all, as well as we have the goodness of bit measurement results. And I think the most important one is these two files, which is the housing synthesis CSV and person synthesis CSV, as well as the weights. So if we only consider weights, we're going to use the weights.
So all the synthesized households is available in the housing file. This is like 4,000 people.
Yeah.
And all the synthesized persons, right?
Yeah.
Individuals is in the person synthetic file.
Yeah, in the file.
And the household weights is available in that weights file.
Yes.
Okay, so if you want to create person weights, do we have any methods to create that?
We just for the
Consider
Equally?
each person.
Yeah.
Represent, have it to be equivalent to a household.
Okay.
So, for example, the household number one, if I have weight is like 2, and this household has 3 people, then we consider the personal weight is each person share 2. Is that's way. Yeah. Okay. So so let's only look at these 3 the first 3 files. Let's look at the weights first. So we're going to run this code to. This is our raw weight file, and it comes with 3 columns. The first one is a household ID because it's a household weight, so each household has a weight. And the second two, the last 2 columns, each one is corresponding to each geo ID. So if this region have like hundreds geo is going to create 100 columns. So, and the sum of all these kind of weights are going to be equal to the total populations of that region. And you can check the number of records in the weights is 14300. And if you consider, if we sum the household sample and the group quarter sample, and then you can find out that it's a match. So it's actually the household weights. So
From before, does that correspond to the region?
It corresponding to entire America. So
that's the
pump.
That's the pumps
Yeah.
records in the region.
Yeah. So
So all the pumps records in the region actually get a weight for each geo.
yeah.
For each geo.
Yeah.
Makes sense. Yeah.
So we want to check whether our weighting rate. Yeah, sorry.
So your weights are actually created for the entire Maricopa County. And then only the synthesizing is done for region map.
So yes, so for the weight is creating for all your survey samples, like how all the synthesis.
But for each geo, so if you believe region 9, you have only the 2 columns.
Right.
Yeah, so that's why he has only the 2 columns, but it's all the sample records.
Yeah.
Right, for the region, and you will wait to match geo 1, then wait again to match geo 2.
Yeah.
Right.
Yeah. So we want to check in the result of weight to see whether this weighting makes sense, like matching the marginal distribution. So we're going to run this code. I want to see compare the weighting distribution and weighting distribution and the margin distribution for each regions. So on this table, because I control all variable as control variable. So you can see that the distribution, the first column is unweighted distribution with the sample distribution. And the second column is a weight distribution, is the after some group by the sum of the weights. And the third column is marginal distribution coming from our like marginal input. As you can see, the difference between the weighted and the marginal is perfectly zero, almost zero. Especially for the household variables, it's just exactly the same. For the personal level variables, it has a small difference, but it's less than 0.3%. So it's very, very small. So that means that our weightings create a very good results. And you can see that for these two regions. And if we sum these two regions, two geos, it's going to be a region 9. As you can see, this is for region 9, which is combined these two geo level. And you can see that the discrepancy between the weighted and marginal is also perfect. So data after, so that means that we have a good weight. And the PopGens, you're going to using this weight, individual weights, as a select probability. And then we're going to start drawing from the samples to create the populations. So the weighting is the first step in the PopGens. And then we're going to see how our synthetic population look like. So which we're going to go to the household synthetic CSV and the personal synthetic CSV. So let's read these two files. So here is our household synthetic data set look like. As you can see that it has one new ID called unique housing ID. So this is the unique ID for this synthetic household table. But it also has the HID. So this HID is actually coming from the sample service. So that means that some households can be like drawn multiple times. So you will have multiple HID. So you know that what it comes from the service sample data set. But this unique house ID is the one we assign for the synthetic housing. And you can see that it has this kind of all these control variables for the personal level and housing level. And the number of records in this housing synthetic is equal to the region number 9, exactly matched. So we can go ahead try to see the personal synthetic file. And it's similar to housing synthetic files. So for the personal synthetic files, you can see that the PopGen creates around 8,988 people, but it's not perfectly matching the marginal data. So we can check here. Let's see. Yeah, we're missing a few people.
What was the marginal total?
So the marginal total, we can see that running this kind of verify to check that. For example, for the housing ones, for the housing variable, you can see. Yeah, let me how to expand it. The left. Yeah, so that's excellent. Yeah. Oh, yeah. So for the household variable or household tables, you can see that it's actually create the synthesis. Yeah. So this is the person one. And for this region number 1, you can see that there's probably 100 less.
Because the algorithm starts when the difference is very minimal, and it always usually stops at when it matches household marginals. And then the difference between person marginals are very minimal.
Yeah. But because this distribution is much distribution very well. So the distribution is perfect, but the numbers It's slightly off. And also for the second region is the same. Like for
Go back to your first graph now and explain us.
okay. Yeah.
Okay.
So now we just like compare. So we want to compare the distribution of the synaptic population to the marginal distribution, right?
So basic defense code is designed in a way that in just one single cell of code, it's going to do all the post-processing comparison of, how did you do in terms of your result. This is what I wanted to produce, right? And let's check the distributions between control variables, what I gave it to you, and what it created. Let's observe the differences and see if anything is problematic.
Yeah, so in order to assess whether our like a synthetic population is valid or not. Yeah, so the first one which is checking the difference between the number grades. As you can see that the number is the same. So that means our population grade for this region geo is good. And then we're going to check the first variable, control variable causal incomes. As you can see that it's perfectly matched. And also for the household size is perfectly matched. And for the personal variable, this employment, it's a little bit slightly differences, but it's just matching really like yeah, it's matching distribution very well. And this is the age variable. As you can see that it shows a good result, and the gender, the sex. And this is for second region. Oh no, the person total, and this is for second region.
So you're matching the households, number of households for the second region as well.
Yeah.
Second geo.
Yeah. And you can see that for second region, it also perfectly match. And the sum of the two geo is one region 9. So that means that for region 9, we also create the good synthetic population. So yeah, that's the overall of the PopGens. Yeah.
So are you able to, let's say you are going to, do a bathing for nationwide, right? For that situation, you have to generate the 350 million people, right? You have to synthesize that. And we don't want to synthesize this because we only want to get weights.
Yeah.
So are you able to disable that in this current version?
Yeah.
So I don't want to synthesize because this is a two-step process, right? First, you create weights, and then based on weights, you synthesize the population, right? So I want to stop. I want option to stop once I create my weights.
Synthesize to 4. Then you can just generate.
Okay, so this is in the configuration file. If you disable that, which means for the synthesizer, you change it to false.
Yeah.
Then it will stop after it creates the base.
Yeah. So if you check the result of the run this one. So if we put false, then you're going to stop it. And then the drawing part will not be shown. So yeah, it's just faster the process if you just want to wait. And also the new version of PopGen can also consider only one region, one marginal level. So not too much level. So that's why we can wait the survey data set to.
So how do you handle that situation right now? How do you handle it? Do you do some manipulation?
No, just
You give them the same region.
You just delete the geo marginal. For example, you only consider one region. You just delete the geo ones and put only regional level variables, and you will shrink your data input to probably only 3.
This, right? Let's say the country level. So I'll just consider it as my first region. So I only have one region. Okay. So I'll prepare my marginal files for that region, right? Yeah. And then I will consider my geos, now my census divisions, right? So this is the 9 census divisions, so that could be considered a lower geographic level.
Yeah.
And I can basically prepare my input files, my marginals for the 9 regions, 9 divisions, right? 9 set geos, basically. And I can just run this.
Yeah.
Right, so I can just treat them this way, and I can run the entire thing to create that.
Yeah, so
Right.
PopGen can handle two levels marginal. So you can use these two marginals to different different resolution for entire different scale, like entire country or county states or
Okay, so it's only 2.
only two.
Okay.
Yeah, only two. But if you want more, maybe I can.
Well, let's say
Theoretically, you could do more.
Yeah, you can
If
do
you
more.
would just get bogged down.
okay.
Yeah.
So what if I don't have any geographic dots, only one them,
Yeah,
right? But in
That
this
is one.
case, do I just delete it, or I am thinking it this way, right? So I have, let's say, one regional level, and then only one geo level, and then they're basically identical the same.
Yeah, you could.
Yeah,
do
you
that.
can do that.
Region,
Yeah.
You could just do region code, that's it.
Okay.
Yeah.
So there's no real variable with the distribution.
Yeah.
You just match it region code.
That's it.
Yeah.
Okay. But then if you provide the same input files, it's basically doing the same thing. Yeah. Okay.
You have any?
So this was county, right? This was county and census tracts.
Yeah.
So for each census tract, the entire county counts is used as the sample, right? For the seed and for rating.
Yeah, so I think if we want to include the PopGens, I think next step we can see the multiple seed. So because frequently we're using one seed as
So we tried that, but then if you try to base the seed on a smaller geography, you have too many seeds.
you don't have.
Yeah, you just
Might
don't
be, yeah.
have enough sample.
Yeah, so.
So the compromise was to maybe use a county level, or sometimes if you have a large Puma, you could use the Puma level as your seed. So all the census tracts within a Puma will get the Puma as their seed. But if your census tracts fall into a different Puma, they'll have a different seed.
This is in the synthesizing part or both?
You know, in the IPF part.
Oh, okay.
Yeah, for the synthesis, for the weights part, right? For the weights part, again, I think it's been, we've done variations. Right, you can take the whole region, you can take Puma, and some Pumas have lots of sample records.
So what if, let's say, instead of having multiple seeds, right? So let's say we have the sample data, so that is from 9 different regions. Right, with the Puma. I can just do separately, right? So take the subsets of the sample records for region 1, do the population synthesis, move on to the next one. So in this case, you are actually accomplishing.
So when we did that, so that's how we started, actually.
Yeah.
If you recall correctly, we tried to have a different seed for each census tract based on which Puma the census tract fell into. And the seed for each census tract would only be based on that Puma sample, that pump sample belonging to that Puma. Which is fine, you could do that, but then we found that in some Pumas where you have very few pumps records, the seed would have too many zeros.
And you may have like overlap problem because some geo may cover like some smaller lower level geo and may not be fully within one Puma.
Right, that is.
So that's kind of overlap
That was
problem
our
issue. That also creates issue. So I think that when you think about multiple states.
But you can still do the manipulations, right? You can just run PopGen multiple times by,
Yes, absolutely.
let's use a different seed for this scenario, for the small, region. And we can just do it for multiple times, and you can create and merge later.
That's how we do this waiting for like you either then some then
Okay.
like, we run the night hand, so it's very fast.
So where people are going to find all of these files? Do you have any website to share these materials?
We have a GitHub.
You have the GitHub?
We have a GitHub, right?
Okay, can you show the GitHub?
Yeah.
Yeah. So yeah, I haven't uploaded this
You can actually go to this.
Mm. TOMNET UTC GitHub. Yeah.
It's gonna be much more easier. No, go to TOMNET UTC dot GitHub dot io or
Tom,
.com.
TOMNET
UTC
UTC.
dot GitHub. I think that's IO. Yeah, let's try that.
Yep.
Okay, so if you go down here. Okay, go down.
Mhm.
Okay, so here is population synthesizer part. So if you click this, this is going to take you to the report.
Yep.
Where you have this, but we are planning to basically have a dedicated web page
Mhm.
to basically give more information about, here are the tutorial materials, here is the recording of this session, here's how you can run on your local machine, and then if you have any questions, here are the contact information. So this is the plan. So when are you going to do that?
This summer.
This summer?
This summer.
That would
This
be-
summer.
If we could do that this summer,
Yeah.
that would be great. We'll set up that web page.
Yeah.
Yeah. Now can you, okay, so, and all of these CSV files, where do they end up? In the data folder?
Yeah, it's in data folders. If you go to a PopGen learning, but no, not this one.
Local machine.
The data and the Arizona, and this is our sample like a sample for PopGens. So we're using Arizona ones for the.
So where is weights.csv?
Oh, this is the. Yeah, this is the output file look like. So after you run it, you have this. Yeah. It's generated after you run the PopGen.
Can you open weights.csv?
Sure.
How many rows is that?
It's going to 143. The total. Yeah, in average. Yeah, we do the ones.
Now the bits are basically going to scale this down.
Mhm.
So that's right, you see the weights are very small.
Yeah.
See,
So-
that's why if you're trying to synthesize
Yeah.
for a small geo,
Mhm.
right, a small geo. We thought that, sometimes it would be better to have the sample restricted to the Puma corresponding to that gene,
Oh, okay.
rather than the entire.
Entire.
sample.
Yeah.
So basically, you have 143,000, and that geo has.
10,000. Oh, 4,000.
Yeah, 4,000.
But I remember last part you mentioned that you want to do the border sample to ensure reach of the sample
Yeah,
size.
so it's kind of a delicate balance.
So it's like a fill out. Yeah.
But these are some tricks you can do, you can try, right,
Mhm.
for different
Yeah.
situations.
Yeah.
Okay, so I think this is what we have for today.